Hi everyone, welcome back to the process. In this session, we are going to discuss about drilling operation. Drilling operations are operations which are used to produce round holes in a work part. Comparing with boring, which is done normally to enlarge a particular hole. There is an existing hole. If you want to enlarge that existing hole, you are using boring. But drilling is basically used to produce holes in a workpiece. Normally, in order to do that, we use a drill bit, and the drill bit is fed vertically downwards to produce a hole. The machine used for this is called a drill press. There are two types of holes produced by drilling operation. First is through holes. The through holes means drill exists opposite side of the work, and the blind hole, the drill does not exit work opposite side. The drill will not exit on the other side. That is called a blind hole. The depth of the hole is taken as D, and here in through hole, the depth of the hole is equal to thickness of the workpiece. Now the cutting conditions of the drilling operation: time required for machining equal to thickness plus an additional distance A, which is called approach, because the drill bit has to move an additional distance called approach A to produce to start the drilling, and then it has to move till downwards. That's why an additional amount of approach A has to be added with T to calculate the total distance or depth traveled by the drill bit. That's why T plus A divided by the velocity, which is the feed rate of the drill bit. Using this, we can calculate the time required for a drilling operation. So the time required for a drilling operation, if it is a through hole means the drill bit exit on the other side, it is equal to T, the thickness of the workpiece, plus approach. Approach is the additional distance traveled by the drill bit to to drill the hole. Using this, we can calculate the time required for machining. Approach can be calculated using the angle of the drill bit using the equation 0.5 d. D is the diameter of the drill. Tan 90 minus theta by 2. Theta is the angle of the drill bit. We can calculate approach. Now you can see here the time. The second case is a blind hole. In blind hole, the drill will not exit on the other side. So the hole depth is equal to D, and hence we can write the equation as time required for machining is equal to depth of the hole. It is the complete depth of the hole divided by feed rate. And the material removal rate can be calculated as area times feed rate. Area is pi over 4d square for the drill bit times feed rate will give you the material removal rate. Reaming is another process which is used to slightly enlarge the hole to give a better finishing and tolerance. Tapping is a process which is used to produce screw threads on the exiting hole. That is called a tapping process. The instrument which is used for this operation is called a tap. Then the drill machines, we have upright drill press or radial drill. Upright drill press, as we have seen in other machines, we have a column to support the components with base, and the head which carries a motor, and power is produced from the motor, and the spindle rotates, and spindle is connected to the drill bit here, and the workpiece is fixed in the table, and the table is moved to and fro. Table can be moved, and also the drilling operation, the drill bit is fed vertically inwards in vertical direction, produce a hole. This is an upright drill hole. We have radial drills, etc. also. Now, work holding for drill presses. There are three types of work holding for drill presses. They are vise, fixture, and drill jigs. Vise is a general purpose work holder with the two jaws. Fixture is a work holding device that is usually custom designed for the particular work part. And drill jig is similar to fixture, but also provides a means of guiding the tool during drilling. Now, that's another process, another important process in manufacturing process is the milling operation. It's a machining operation in which work is fed past to the rotating tool with multiple cutting edges. So milling is an operation which is done with the multiple cutting edges. Axis of the tool of rotation is perpendicular to the feed. It generally creates a flat surface or a plane surface. So this can be explained by using, this can be done, the process, the milling operation can be done with the help of a machine which is called a milling machine. So multiple cutting edge tool in a machine called milling machine used to produce plane surface or flat surface called a milling operation. A large amount of material can be removed. There are two types of milling operation, peripheral milling and face milling. In peripheral milling, the milling operation is done using a multiple cutting edges on the periphery of the milling cutter. The axis of the workpiece, the axis of the milling cutter and the surface are parallel. If the axis of the milling cutter and surface are perpendicular, it is called a face milling. Using the face, we remove the material. We call it as a face milling, in which the axis of the milling cutter and the axis of the surface are perpendicular. So peripheral milling, as I explained before, peripheral and face milling, peripheral cutting axis parallel to the workpiece, face milling cutting axis perpendicular to the workpiece. Then slab milling. What is the meaning of slab milling? You can see an extension here. It's a form of peripheral milling in which the cutter width extends beyond the workpiece on both sides. This is called slab milling. Slotting process means width of the cutter is much less than the workpiece width, creating a slot. So creating a slot can be done by a process called a slotting process. And then a conventional face milling, cutter overhangs both on sides, so complete amount of material can be removed from the workpiece, conventional face milling. And in end milling process, cutter diameter is less than the work width, so a slot can be produced. This is called an end milling process. Similarly, we have profile milling process in which outside periphery of a flat part is cut to produce a profiles, etc. This is called the curved shapes, etc. This is called a profile milling process. Pocket milling process is another form of end milling to which mill show shallow pockets into the flat parts. You can see shallow pockets can be produced using an end milling process. This process is particularly called as a pocket milling process. Surface contouring process, the ball nose cutter fed back and forth across work along a curvilinear path at close intervals to create a three-dimensional surface. Now, vertical and horizontal milling machines, you can see here, this milling machine is peripheral milling, and this is for face milling operation. You can see here the spindle is connected with the motor. As the motor rotates, the spindle carries a cutter. Cutter also will rotate. So the workpiece is fixed in the table, and the work table can be moved to and fro, and then up and down, and then by moving the work table we can cut the material. So this is called this is a milling operation similar to other machines. It will have a base and column for the supports, and there will be a motor to feed to produce a power. The rotational speed is produced by the motor, and there are arrangements to fix. There is a spindle to connect the milling cutter, and a work table to fix the workpiece and move up and down horizontally, etc. So this is the basic parameters of a milling machine, and there are peripheral as well as face milling operations. What equations could be used for milling operations? The speed required, the rotational speed, as we studied before, cutting speed V divided by pi d. D is the diameter of the cutter, and then here feed rate can be calculated as NNTF. N is the cutting rotational speed, F is the feed in millimeter per revolution, NT is the number of teeth on the cutter. Using this, we can calculate the feed rate, and material removal rate can be calculated as WD times FR. W is the width, D is the depth, so it becomes the area of cut times feed rate will give us the material removal rate. And when we analyze a milling operation in a slab milling operation, the milling cutter travels an additional distance of approach A. You can see here we have to cut this product on the surface at a depth of cut D. So milling cutter advances at a distance A. So total distance traveled by the milling cutter will be length of the workpiece plus approach A. So L plus A divided by feed rate. A is the approach, which is equal to square root of D times capital D minus D. Small d is the depth of cut, and capital D is the diameter of the cutter. Now you can see here. So this is the equation we use for a slab milling. Now we come to a face milling operation. in a face milling operation, what we have is these equations. In a face milling operation, you see here, this is the first condition. So here the approach is calculated, is the approach is taken here. So in a face milling process, consider the two possible cases. This is the first case and this is the second case. The first case is when the cutter is centered. This is the cutter is centered over a rectangular workpiece. Here cutter is centered over a rectangular workpiece. The cutter feeds from right to left across the workpiece. In order for the cutter to reach the full depth of the work, it must travel an approach distance given by the following. So it has to travel an approach distance which is equal to A equal to 0.5 D minus square root of D square minus W square. D is the cutter diameter, W is the width of the workpiece, A is the approach. So different conditions like D is equal to W, then approach equal to 0.5 D, etc. are applied here. Now in the figure 2, here the cutter is offset to one side of the work. Cutter is offset to one side of the work, as you could see here. In such cases, approach can be calculated as A equal to square root of W times D minus W. W is the width and D is the diameter. And the time required for machining is the total distance traveled, which is L plus A divided by feed rate. L is the length of the workpiece and A is the approach. So machining centers are highly automated machine tools that can perform multiple operations under CNC control in one setup. That is called machine centers. Typical operations are for milling and drilling. 3, 4, or 5 axes are available, and important features are automatic tool changes. Tool changes can be done automatically, and automatic work part positioning, etc. Thank you very much for listening. Thank you.